In this video, we will talk about the concept of coding to supertype, polymorphism, and how everything comes back together to solve the bigger problems. So we will see how we can simplify the design using the concepts of inheritance, whether it is interfaces or abstract classes or simply parent classes. So let's start. So in this video, we will see a quick example on inheritance and supertypes, and we will try to link everything together. We will see how can we simplify the design by using the concepts of inheritance, abstract classes, interfaces. So let's assume we have a requirement to load some data from the drive. So what we did, we created a drive loader class, and there are two methods is configured, which returns a boolean. So the meaning is the loader will return if this is configured, if this is active to load the data. So it returns true. Then we have the load method, and the purpose of the load method is to load the data from local drive. Right now, this is simply printing a message that I'm loading from local drive. Then the requirement came to support the network resource loader, which means the requirement came so that we can read some resources, we can read the data from a network drive, a drive that is connected on the network, same as Samba, for example, in Windows. So if we are not using inheritance, what we can do maybe, or what we did actually, that we created a new class, network resource loader, and we kind of duplicated the class. So it has the same method, is configured, returns true, and the load method with the same name and everything. The only difference is the implementation. For this class, the load implementation will be to load the resource from the network. So it has a different print message loading from network drive. Now the thing is we have to create the objects of these classes depending on what we want to use. So we need to understand the pattern here, because the same pattern would be buried deep inside a complex code, but the problem remains the same. So we have similar looking classes with similar functionalities with some differences. Now we need to initialize them and use them somewhere. So for example, here we have a method load resource, and the in the load resource, what it does, it loads a loader, it instantiates a loader, it then checks if the loader is configured. If yes, then it calls the load method. So earlier when we had only drive loader, so we wrote a code similar to this, that initialize drive loader, create a new object of drive loader, then check if the loader is configured, and then call the load method. But when we added network resource loader, a new class, then we cannot create instances of all the classes at once. It depends which type of flow do we want to execute. If we want to run drive loader, then of course we will create the instance of drive loader. But if we want to create, if we want to call the network loader, then we have to create the instance of network loader and call its is configured and load methods. So to handle that, what we did, we said that let's use some parameter, some runtime parameter to distinguish whether it is the local load flow or the network load flow. So we pass the parameter from the startup command in this case because it's a simple example, and we fetched that type, basically the value that we passed from the startup command. Then we pass the value to the load resource, and we are checking that if the type is local, so create the object of drive loader and call its methods. But if the type is network, then create the instance of network resource loader. Now, do you see the problem? Let's say we have to add another resource loader. Then that means we will duplicate the same code, and we will have to add a new else if here in this block, that else if a new type is there, then create the object of that type and call its configured and load method. So you see the problem of duplication and how it is complicating uh, the existing code. And if we have to support many resource loaders, then it will be a big method, the load resource, a big method with lots of if else if, which will be difficult to test and difficult to add new resource loaders. So we already understand the concept of inheritance. So let's simplify this with the use of inheritance. So if we focus on these two classes, drive loader and network resource loader, so we already see a common behavior, that one part is to check if the loader is active, and the second part is to actually load the call the load implementation. So let's add a new parent class. Let's first create the inheritance hierarchy for these type of loaders. So let's name it generic loader. In the generic loader class, there will be one method to check if this loader is configured or not. So name it is configured, same name. And by default, the default implementation will return true. So we will assume all the loaders will be enabled by default. Then we will define a load method, and we see that because each loader is different, we don't know the default load implementation. So what we can do at this stage, we can simply leave the method empty with a comment, let's say does nothing. But there is a better solution in case we know the behavior but we don't know the default implementation. So we can simply create an abstract class and we can say I don't want to give the implementation of load with an abstract method. So we created a parent class, abstract class, and we defined the isConfigured method with default returning true, and then an abstract method with the name load. Now, let's go to the drive loader. This class will extend the newly created generic loader. Now we see because we are saying that all the loaders will be enabled by default, so we don't really need to write this is configured. It will get this method from the parent. But because this is the abstract method, we have to provide the implementation which we are doing. So we don't really need to do anything. We simply need to remove is configured. But you see the drive loader class, we simplified the class a bit. It looks cleaner. Similarly, we'll go to the network resource loader and extend the generic loader, remove the is configured, and now we simply have the load method and with their corresponding implementations. Okay, what's the next step? Next step is to simplify this bit. How can we avoid these if else if statements, and how can we make the load resource method generic? So what we can do actually, instead of putting if and else if blocks and passing the type, we let's create a new method so that we can compare public static void and load resource. Let's name it generic this time. So because we have a parent type, we have the parent type that all the loaders all the loaders will inherit from the generic loader. So generic loader is at the top in the inheritance hierarchy. Instead of putting different conditional blocks, what we can say that okay, this method will accept a parameter of type generic loader. So we are passing the object of type object of type generic loader to the method. Now in the method, because generic loader The class generic loader has two methods, is configured and load. So we can simply do if generic loader dot is configured, then generic loader dot load. Okay. You see that the method has changed drastically if we compare the implementation with this method, because we are using the super type. So we are saying that if we are passing the super type, then we know the methods supported by this particular type, and we are simply calling the is configured and load method. All right, we are not passing the actual object here, but we are working with the reference variable of type generic loader. So we can say this implementation that yes, call the is configured and call the dot load method. There are no problems in this way. All right, now let's see how do we pass the actual object here. So we still need to distinguish what we need to instantiate. So we still have the type parameter, but instead of duplicating everything, what we will do here is we'll say that, okay, generic loader, initialize it with null. At this stage, we don't know what kind of loader we have, but if type is local, same check that we were using here, but now we are saying that if this type is local, then initialize the loader with drive loader, and else if type is network, and initialize the type with new network loader. And instead of calling the old method, we are saying that just pass the loader object here. That's it. Okay, so let me move the message after the main method so that it's easier to understand. So we are saying that create the new object of loader, and on the left hand side the reference variable is of type generic loader, but depending on the type passed, we are actually creating the object of a specific loader, a drive loader or a network resource loader, and then we are passing that object to the load resource generic method, which which has an object of a very specific type. But because we are dealing with the reference variable of super types, so we know that it can accept any type that is actually a type of generic loader. So it will work, this assignment will work, and at runtime the methods that will be called upon this object will actually belong to the actual object. So we already understand this, that the left hand side, what kind of methods can be called is decided by the reference variable or the type of the reference variable declared on the left hand side, but the actual object on which the methods will be invoked is decided by the right hand side. So we can use this concept, and that's how the inheritance simplifies the overall design. Similarly, let's say if we have an interface. So let me quickly create an interface probably, and we will see another example. So let's name it custom interface, and let's put a method here, void apply. Okay. Now what we can do, a class can extend from another class, and it can also implement an interface at the same time. So we will say that drive loader will extend from generic loader, but at the same time it will implement the custom interface in custom interface. And do that, we'll have to implement the methods in the from the from the interface, so apply method, and we say that okay, drive apply. Similarly, we can also change the network resource loader and add the missing method. All right. So now all the loaders have three methods actually. One is configured, which they are deriving from the parent class generic loader. Then they are overriding the load method, abstract method defined in the parent class. Then there is one additional method apply that they have to implement because they all are implementing the new interface. Now, what we did with the inheritance in the load resource generic method, we can do the same thing with interfaces. So, because the pattern that we follow is that super type reference variable equals to new any subtype from the same hierarchy. So that's how we can initialize the objects. On the left hand side, we always give the super type, and on the right hand side, we create the specific object, the subclass or the subtype from the same hierarchy. So if we see that we are following the same pattern here, on the left hand side, we are providing the super type, which is generic loader. But depending on the condition on the right hand side, we are creating the objects of subclasses. And then we call the method that we defined in the super type. So the benefit is that the code that is using the ref is no longer tied to the subclasses. So we simply put the super type there and we can replace the ref with any subtype at any point of time if we instantiate a new subclass, and there will be no need to change anything. So for example, if there is a new type introduced, then all we need to do is to initialize that new type, but there will be no change in the load resource generic method because here we are dealing with the super type. So this is also known as coding to super type, and this is also we can say is the polymorphism. We are using the polymorphism here because what polymorphism says that one type can have many forms. And here we are saying that one type, which is basically super type, the reference of super type can have many forms depending on the type that we are initializing. So for example, if the type is local, then the same loader of type generic loader has a form of drive loader. But if the type is network, then the same form is behaving as a type of network resource loader. So this is polymorphism. And the same thing we can do with interfaces. So let's say we have another method, void by configs, for example. We can say that okay, this method will actually uh, accept any type that is implementing the custom interface. So instead of passing the actual type here, what we can say, okay, pass me any implementation object of any implementation that implements this interface. So let's say we name it any object. Now in this method we can simply say any object dot apply, because that is the method we defined in the interface. Now in the apply configs, in the apply configs, we can either pass drive loader or network loader. It will be fine if we pass the drive loader or the generic loader. There will be no error because these types are actually implementing the interface. So we split it out, the object creation and the way we are using that object, because in the method the type is no longer dependent on the subclasses, it is dependent on the super type. So at runtime, depending on the condition, we can always pass the subclass, subtype, or any class that is implementing an interface or inheriting from a class. So that's how they all link together, and that's how they simplify the overall design, they simplify the problem. And we learned about the concept of coding to supertype and polymorphism. So hope this helps. That's it for now. Thank you.